Hey there, welcome to the third episode of the Rhino for Absolute Beginners series. I'm Hossein, and I'm super excited to be here with you as we dive into the world of digital design and the Rhino environment step by step. So, this series is broken down into 4 parts, right? And it's all about helping you grasp those essential Rhino concepts in a really straightforward and practical way. In the first episode, we got acquainted with the logic of digital design and the software environment, which was pretty cool. Then, in the second episode, we learned how to draw accurately and build a solid mental foundation for modeling, which is like super important. And now, in this episode, we're jumping into one of the most exciting parts of Rhino. We're going to explore how to transform curves and lines into surfaces and volumes and, oh man, create complex forms using various commands. All right, so check this out. In the video timeline, all the commands are marked, right? So you can just dive straight into the command you want and practice way faster. Let's get into the tutorial. All right, so we're talking about turning curves into surfaces here, right? So like this command, it creates a planar surface from a bunch of, planar curves that define the edges of the surface. But there are actually 2 main rules you really got to follow, like at the same time, or else, well, you won't get that surface. First off, the line, it has to be closed, like totally closed and not open at all, And then the second thing is it has to be flat, like really flat or planar and no twists or turns, just straight up flat. If one of these rules is broken, poof, no surface for you. So like the difference between surface and solid in Rhino, it's like totally about being closed and, having volume. So a surface, right? It's just this 2-dimensional shell in a 3-dimensional space. I mean, it has no thickness like at all. It's just made up of one or more surfaces that don't really have defined edges, kind of like a piece of paper or the skin of a sphere, So check this out. If you use Loft or Sweep to create a shape and the edges don't meet up, what you get is an open surface. All right, so here's the deal, right? A solid is made up of several surfaces and all the edges are totally connected, creating this completely closed volume. You know what I mean? Like think of a cube or a closed sphere in Rhino. That's a solid. This kind of geometry is super important for things like 3D printing, calculating volume, or doing Boolean operations like union, subtract, intersect. You get it? Because the software needs to know it's a fully closed object to do those volume calculations. Every solid is made of surfaces, but not every surface is like a solid. All right, so here we go with this solid creation cascade thing, right? So you start with the box, and it's like corner to corner. The box command, it creates this extrusion box, which is pretty neat. So here's the deal. First, you pick 2 points for the opposite corners of the base rectangle. And if you press and hold shift, you can totally draw a square. Or, if you're feeling adventurous, you can select one of those options to draw the rectangle differently. Then you're going to pick the height, right? Just press enter to use the width value for the height. Easy peasy. Now, box diagonal. Oh, this is cool. It creates a box from the diagonal corners. If you pick 2 corners on the CP plane, the command will prompt you to pick the height. All right, so check this out, right? You've got this box 3-point thing, yeah? It draws a rectangle using 2 adjacent corner spots and then a location on the opposite side. Pretty neat, huh? And then there's this cylinder command, it's all about drawing an extrusion cylinder. So first step, draw the base circle. Super simple, right? Then you either pick a spot or type a number to set the height. And the direction constraint options, they totally define the positive height differently. All right, so let's talk about the sphere command for a sec. So like it draws this solid sphere, right? You create it by picking a center point and then like a radius point. Super simple, but kind of fascinating when you think about it, huh? Now, moving on to the ellipsoid. Oh man, this one's cool too. So like the ellipsoid command draws a solid NURBS ellipsoid, which is just a fancy way of saying it's a 3D shape. You create it by like defining the half length of each axis. All right, so like let's talk about this paraboloid thing, yeah? So the paraboloid command is all about drawing this parabolic surface, right? So here are the steps, like super simple. First, you got to pick the focus. Yeah, that's important. Then you choose a direction, and that's the open direction, just so you know. And then you pick the end, which is like crucial. Oh, and don't forget the focus to vertex distance and the length of the parabola. Yeah, that's going to show up at the command prompt. Pretty neat, huh? Now, moving on to the cone. The cone command is all about creating this surface cone. So first up, you draw the base polygon. You know, check out the polygon command for all those option descriptions. Then you pick the end of the pyramid, right? Or you can just type a value to set the height. Easy peasy. All right, so here's the deal with the truncated cone, right? So the truncated cone command, it's like, it draws this cone, but wait for it, its apex gets cut off by a plane. Crazy, right? So first things first, you want to draw the base circle. Simple enough, yeah? Then you pick a location or just type in a number to set the height. But here's the kicker. The positive direction of the height, it changes depending on the direction constraint option you choose. Wild, right? And then you finish it off by drawing the end circle. Now let's talk about the pyramid. The pyramid command, oh man, it draws a pyramid. So you kick things off by drawing the base polygon. Don't forget to check out the polygon command for all those option details. Next up, you got to pick the end of the pyramid, the apex, or just type in a value to set the height. Easy peasy. So yeah, that's how you do it. Okay, so like we're talking about this truncated pyramid thing, right? So first, you want to start by drawing the base polygon. I mean, seriously, check out the polygon command for all those option details. Then you got to pick where the end of this truncated pyramid is going to be. Or like you can just type in a number to set the height, which is super easy. If you type in a positive number, it goes up towards your mouse cursor. But if it's negative, it goes down, like, away from it. Crazy, right? And then, don't forget to specify the radius of the top polygon. It's all about those details, you know? All right, so let's talk about the tube, yeah? So the tube command, it's like super cool because it draws this closed cylinder, right? And it's got this concentric cylindrical hole in the middle. So first things first, you want to pick the center and the radius of the base. Yeah, just check out the circle command for all the options and stuff. Then, after you've drawn that base circle, you're going to want to pick the radius or diameter for the second tube wall. It's pretty straightforward, yeah? And then you just pick the end of the tube or like type in a height. Super simple. Now, moving on to the torus, okay? This command, it's all about drawing a torus, which is basically a donut shape, right? How fun is that? So you can just imagine like creating your own donut shape in whatever design you want. All right, so check this out. The pipe command, right? It creates this like surface with a circular profile around curves. So here's what you got to do, okay? First, you pick one curve. Easy peasy. Then you choose the start radius at the beginning of the pipe. Like super important. If the curve is closed, you got to pick the radius for the pipe. Got it? Next, you pick the radius at the end of the pipe. And, you can either pick a point for the next radius or just press enter to wrap it all up. Now, with the pipe round caps, It's basically the same process as the flat caps, but wait for it. This time, it rounds off the ends of each pipe. All right, so check this out. When you want to like extrude closed planar curves, right? This command, it creates a surface by like tracing the path of a curve in a straight line. Pretty neat, huh? So here's what you got to do. Step 1, select a curve. Yeah. Then step 2, specify a distance. Easy peasy. Now, moving on to extrude surface. This command is all about creating a solid by tracing the path of the surface edges in a straight line. Super cool. So here's how it goes. Step 1, select a surface. Got it? And then step 2, specify a distance. And that's it. All right, so let's dive into how to create a surface, right? First up, we've got the patch command. So like this command is super cool because it actually fits a surface through selected curves, meshes, point objects, and even point clouds. Now, here are the steps, okay? First, you got to select those point objects, curves, and edges that you want to base your patch on. Got it? Then you just specify the options. It's like super straightforward. I mean, who knew making surfaces could be so simple? Okay, so like let's talk about this command, right? It's called network surface. So what it does is it creates a surface from like a network of crossing curves. So here's what you got to do, all right? First, you pick the curves in 2 directions that totally form this network. Or you can just use, Windows selection if you want. Super easy, right? Like, seriously, who knew it could be this simple? All right, so like, let's talk about the Loft command. Yeah? It's all about fitting a surface through these profile curves, right? That totally defines how the surface is going to look. So here's what you do. First, you've got to select those curves, but like in the order you want the surface to pass through them, super important. And then make sure you pick those open curves that are like near the same ends. If they're closed curves, you might need to adjust the seams. Like for real, it's all about getting that shape just right. It's so fascinating. All right, so here's the thing, right? You're going to want to sweep one rail, yeah? So what this sweep one command does is it actually fits a surface through a series of profile curves, which, get this, define the surface cross sections. And then there's this one curve that's all about the surface edge. So here's how you do it. Step by step. 1. First, you got to select a single rail curve. Just one, okay? 2, then you pick those cross-section curves in the exact order that the surface will pass through them. Super important. Oh, and just a heads up, if you're selecting multiple closed cross-section curves, there's going to be an extra step to adjust those curve seams. So keep that in mind. All right, so let's talk about this sweep 2 thing, yeah? So you're going to want to fit a surface through these profile curves that like totally define the shape, right? And then you need like 2 curves that are going to set the edges of the surface. Okay, so here's what you do. First, select those 2 curves, they're your rails, yeah? Then you grab those cross-section curves in the order that the surface is going to pass through them. Just make sure the open curves are near the same ends, okay? And if you're dealing with closed curves, you got to adjust the seams like real careful. It's all about getting that perfect fit. All right, so let's talk about this revolve command, right? So like it creates this surface or sub D, and it does that by revolving a profile curve, which is basically the shape of the surface around an axis. Pretty neat, huh? Okay, so here are the steps, right? First, you got to select your curves. Got that? Then you pick where the start of your revolve axis is. Like, where does it all begin? Next, you pick the end of the revolve axis, or like you can just press enter if you want to use the C-plane Z direction. Super easy. And oh, by the way, the start and end of the revolve axis can totally be attached to existing objects using object snaps if you have history recorded. How handy is that? Finally, you just need to specify your options. And voila, you're all set to create something amazing. Isn't that just fascinating? Okay, so like when we talk about extruding straight, right? It's all about drawing a surface or a curve along a straight line to create this awesome 3D volume. You just pick the curve and then like you either enter the extrusion height or just drag it with your mouse. Super simple, right? Now, for extruding along a curve, it's like totally different. You're going to extrude a curve following the path of another curve. So first you select your profile and then like you got to specify the path curve. So if you're really enjoying this tutorial, like seriously, please consider subscribing and turning on that bell. It totally helps the channel grow, you know, and don't forget like to smash that like button and share this video with your friends who might find it super useful. Oh, and by the way, this series is just the beginning. I mean, we've got some seriously exciting project-based Rhino modeling, Grasshopper, and Python tutorials coming up soon right here on the channel. Also, I'd love to hear your thoughts, so like make sure to drop a comment below. All right, so Solid Tools Cascade, right? This cascade is all about those like methods for editing volumes, you know? And then we get to Booleans like the Boolean union command. So what it does is it trims those shared areas of like selected polysurfaces or surfaces, and then get this, it creates a single polysurface from the unshared areas. Pretty wild, huh? So here's how it goes. You select the objects, and then you just press enter, and voila. The objects, they just combine into one polysurface. Okay, so like let's talk about Booleans, right? So the Boolean difference command is kind of interesting, actually. It trims those shared areas of selected polysurfaces or surfaces with like another set of polysurfaces or surfaces. How cool is that? So here's what you do, right? First, you select the surfaces or polysurfaces that you want to subtract from, just like hit enter after that, yeah? Then you move on to select the surfaces or polysurfaces that you want to subtract with, and of course hit enter again. All right, so here we go. Booleans, right? So like the Boolean intersection command, it's all about trimming away those unshared areas of your selected polysurfaces or surfaces. Super neat, huh? So first things first, you got to select your first set of objects, or maybe a set that's intersecting, and then like just press enter, easy peasy, right? And then if you did pick that first set of objects, you want to go ahead and select the second set of objects and boom, press enter again. It's like magic. How cool is that? All right, so like check this out. We're talking about Booleans, right? So there's this thing called the Boolean split command, and it's pretty neat. It splits shared areas of selected polysurfaces or surfaces, which is super handy. You can create separate polysurfaces from both the shared parts and the unshared parts. Okay, so here are the steps, right? First, you select your first set of objects and like just hit enter. Easy peasy. Then you select your cutting objects and again, just press enter. Oh, and get this. Your cutting objects and the objects to split can totally be the same. All right, so check this out, right? The fillet edge command, it's like super cool because it creates this smooth tangent surface between polysurface edges. But here's the kicker. It uses these varying radius values. Then it trims and joins the original faces to the fillet surfaces. Isn't that neat? So here's how you do it. Step one, you just got to select those edges. Or if you're feeling fancy, you can double click on an edge to grab those tangent edges. And then step two, you edit the radius handles and options. It's like totally customizable. How awesome is that? All right, so like we're talking about the chamfer edge command, right? It creates this ruled surface between those selected polysurface edges. And get this, you can have varying chamfer distances. How awesome is that? It trims and joins those chamfer surfaces to the main surface. So here's what you do. First, select the edges. Or you can totally double click an edge to grab those tangent edges. So slick, right? 2, then you just edit those chamfer distance handles and options. Super straightforward. And hey, there are like tons of other advanced commands out there that are super useful. If I tried to cover all of them in this video, we'd be here for like 10 hours. So why not give them a test yourself? I'm thinking of making a separate video just for those advanced commands that are really practical from these cascades. Sounds good? All right. So we're talking about this like curve from Objects Cascade, right? It's all about those different tools for extracting lines from shapes. So like here's the deal with the duplicate edge command. Okay, it like creates curves from the edges of a surface, mesh, or sub-D object. So here's what you do. First, you select the edges of a surface, mesh, or sub-D object. And if you need to, you can Ctrl+click to like deselect an edge. Easy peasy, right? Just keep that in mind. Okay, so like duplicate border, right? So this command, it creates these super neat curves from the boundaries of whatever objects you've selected. And then there's this thing called duplicate face border. So this command, like it makes a curve that duplicates the border of a polysurface face. How cool is that? So here are the steps, yeah? First, you just select a surface or a polysurface face, and then like you press enter. It's as easy as that. All right, so check this out. When you're talking about project curves, right? The project command, it's like it moves your input objects, in the direction you want towards those target objects just to find where they intersect. So like step 1, you got to select those curves and points you want to project. And then step 2, you pick your target object, easy peasy. Now, moving on to pull curve. Oh man, this one's cool too. The pull command, it's all about moving those input objects towards the normal direction of your target objects, just to find those intersections, So like first step, select your curves or points that you want to pull. And then, you select that target object. All right, so here we go, right? The section command, it's like super interesting, It creates these planar curves, points, or even hatches by like intersecting a plane with the input objects. So check this out. First step, you want to select the objects for section creation. Easy peasy, right? Then you just pick 2 points to define that section plane. And oh, by the way, the section planes are going to be like perpendicular to the current CP plane. How cool is that? Just imagine the possibilities. Okay, so like let's talk about this contour command, right? It's super interesting. So it creates these like planar curves, points, or hatches by intersecting evenly spaced planes with whatever input objects you've got. So first things first, you got to select the objects for contour creation, right? Easy enough. Then you pick your base point. And here's the cool part. The contour planes, they start generating from that base point and like go in both directions. Next up, you want to pick a direction that's like perpendicular to those contour planes. That's key. And then, this is important, specify the distance between the contours. Just remember, the contour planes are going to be perpendicular to the current CP plane. All right, so like let's talk about intersections, right? So the intersect command, it's kind of neat actually. It creates these point objects or curves right at the intersection of two objects. Okay, so here's what you do. First, you select your objects, and like that's it. Boom. You get these curves or point objects right at the intersection. All right, so here's the deal. In this episode, we totally learned how to create surfaces and volumes using lines and curves, right? And with all those different commands, we can whip up some seriously complex forms. We got familiar with the difference between surface and solid, and oh man, we saw how tools like Loft, Sweep, Extrude, and Revolve, along with Boolean commands, can help us craft precise 3D models that are ready for printing or rendering. It's like this part is the crucial connection between 2D drawing and 3D modeling, where design literally transforms from a line into a volume. If you're keen on continuing this educational journey and leveling up your skills, make sure to subscribe to the channel and give this video a thumbs up.